Every day, humans and machines generate 2,5 hexabytes of data. Heartbeat sensors on your watch, the accelerometer inside your smartphone, emails you send and receive, the seconds your screen stays on a product, pictures you snap, likes on Facebook, or the movement of your fingers on the touchpad, are logged on servers. The velocity of influx, variety of form and amount of volume of this data, makes them so distinct, as to have to give them a new name.
Big data is a phrase used to mean a massive volume of both structured and unstructured data that is so large it is difficult to process using traditional database and software techniques. In most enterprise scenarios, the volume of data is too big, or it moves too fast, or it exceeds current processing capacity. Big data has the potential to help companies improve operations and make faster, more intelligent decisions. This data, when captured, formatted, manipulated, stored, and analyzed, can help a company to gain useful insight to increase revenues, get or retain customers, and improve operations.
Companies might actually own big data, and face the need to mine them, in order to harvest insight on their activities, or they can benefit by using third-party services that are a product of big data analysis. We are going to portray both cases, but before that we need to address what type of professionals work with big data, and roughly how they do that.
Hadoop is an open-source ecosystem of simple programming models for distributed processing of large datasets. The IT team, or the data engineers or data developers, set and maintain this platform that the analysts, or analytics team, are going to use on a daily basis. The analysts use a framework, like Hadoop, in order to extract, review, transform, normalize or reduce the data, usually in parts, and then aggregate the results. This process usually takes months. The data scientist, or the business person, has a strategic role over the process, navigating the teams in order to mine very specific answers to complex problems.
Smart size. Personalized online experience. Big data is becoming essential to our society as technology grows and more people are becoming accustomed to using the internet for their everyday needs. The online growth of businesses could become a problem for some of their customers because of the loss of human connection. The social aspect of walking into a shop is disappearing, and as we move online this could become a problem as many people do not really know what they want, or need, and might need a person to guide them. This is where big data can benefit many online businesses. Big data allows businesses to bring back that personal touch we miss from entering a shop. By collecting various amounts of data on each customer's past behavior, for example online searches, where they live and how they react with social media online, companies can mine this information and increase customers' satisfaction and potential sales. An example of this is used on some online fashion stores. Many people struggle when it comes to buying clothing online. The brands aren't always the same fit, and without being able to try on the clothing it is hard to guess whether they are the right size. By using big data we are able to tackle this problem, and one Danish company have used this to come up with a set of sizing intelligence tools which builds the trust between online fashion stores and their customers. The way it works is where online fashion stores implement an interface which allows online shoppers to focus on shopping rather than being delayed by approximating their sizes or distracted by questions and measurements. The only thing a client needs to add is a brand size, which fits him, her best, and their brand conversion tool will convert it to the desired brand size. This new technology allows online fashion stores to achieve higher conversions as well as lower returns, therefore improving the customer's online shopping experience.
Smart City. 18th of May 2016, City of Copenhagen launched world's first big data platform for cities. The work was done in close collaboration with Japanese Hitachi Consulting Corporation. This solution establishes a citywide data marketplace for data owned by public authorities and private companies, and presents a novel approach to a common issue of data availability. The name of the marketplace is the City Data Exchange. The City Data Exchange is a software-as-a-service solution that will allow for the sale, purchase and sharing of a wide variety of data from multiple sources among all types of users in a city: citizens, city government, businesses. The purpose of the City Data Exchange is to collect data from public and private data owners and make it readily available for consumption by other public and private entities. Cities are increasingly using intelligent technology to connect public and private stakeholders with the goal of making cities smarter, safer and more sustainable. How real-time data is connected and used to take smarter actions will play a key role in improving public safety, and making our cities smarter. By integrating video feeds, event data and other sources such as social media on a single pane of glass, Hitachi Visualization Suite provides real-time information and insight. Hitachi Visualization Suite is a hybrid, cloud-based platform that integrates disparate data and video assets from public safety systems, 911 computer-aided dispatch, license plate readers, gunshot sensors, and so on, in real time and presents them geospatially. HVS provides law enforcement with critical insight to improve intelligence, enhance investigative capabilities and increase operational efficiencies. The algorithms can also be used to create threat-level predictions to accurately forecast where crimes are likely to occur, or additional resources are likely to be needed.
With every new technology, new ethical problems arise. Big data bring to the surface issues of anonymity, privacy and confidentiality. Big data analysis has also some other ethical issues that should be considered when looking for answers. Results can be potentially biased, meaning that algorithms are only as neutral as the rules and data they are given. Another fact to keep in mind is that analyses are limited simplifications. Just because machine learning came to a conclusion, it doesn't mean that the conclusion is true. Results need to be interpreted by humans,